We are covering repetition structures this week, and C# includes four while loops, do while loops, for each loops, and for loops. We are going to be covering while, do while, and for loops because those go with the data types that we have learned so far. A for each loop is typically used with an array or a collection. And once we cover arrays, you will learn about the for each loop. So we'll start with the for loop, and a for loop works well when you know ahead of time how many times you need to execute the loop. Okay, so the number of times is known in advance. And to create one of these, you use the keyword for, and then there are three expressions. And you will notice that they are separated by semicolons. And expression 2 is the only one that is required. The semicolons are also required because that's how C# knows where expression 1, 2, and 3 are located. Expression 2 is the condition that it is checking. Expression 1 is normally a counter. So you're going to count up the number of times you have looped. And expression 3 is used to increase or decrease the counter. If you don't include expression 1 and expression 3, you still need the semicolons. And I would tell you to use a while loop or a for or a do while loop. A for loop, if you're not going to use expression 1 and 3, it's silly to use it. Okay, so this loop is really designed for 3 expressions. So how does this look? In this example, you can create the counter and set it to a beginning value, which if you are going to increase the counter, the beginning value is typically 0 or 1. Then you're going to check the counter. This is your condition. So we set size to 50. We want to do the loop 50 times. So this is going to test true as long as the counter is less than 50. And then each time we are processing the loop, it's going to increase by 1. So how this works is we start at 0, and it's going to actually print out a 0 because that counts as one iteration of our loop. Okay, and it's going to get to 49. 49 is less than 50, so it's going to write that out. And at that point, because we started at 0, it has looped 50 times. Okay, so when we're at 49, it is going to print out 49, and it's going to increase the counter to 50. And then when we come up here, well, 50 is not less than 50, so this is now false. So it's going to go to the line below. And I have this set up in a little test demo for you. And so you can see this is exactly what you were just looking at. So I'm going to run it. And you can see we started on 0. And we go to 49. That 0 does count as an iteration. So it did run 50 times. Now, if you don't like starting at 0, you can start at 1. But then we need to adjust our condition, because if you start at 1 and you leave it at less than, it is only going to run 49 times because now it's not running that first 0 iteration. And when it gets to 50, it's going to stop because 50 is not less than 50. So I will show you. And so it started at 1. It ended at 49. So we are 1 short. This is called an off by 1 error. So to fix this, there's several different things you can do. The easiest thing is to change the operator to less than or equal to. So when it gets to 50, well, 50 is less than or equal to. It's actually equal to, so then it will process the loop. And it's only going to stop when the counter gets to 51. So if we run the code now, you can see it actually did run 50 times and it started at 1. Another way that you can get an off by 1 error is by doing this. So if we start at 0 and we say less than or equal to 50, it's going to loop that first time with a counter at 0. It is also going to loop when the counter is 50. So it's going to loop 51 times. So it's going to do 1 too many. Okay, so we've got the 50th here, but we also have this one, which we have to add in. So it has looped 51 times. So it does 1 too many, which is also an off by 1 error. Easy fix. If you start at 0, you want to use less than. If you start at 1, you're going to choose less than or equal to. In addition to incrementing a counter, you can decrease a counter. So let me show you how that works. So I'm just moving these little comments. So with decrementing, you set your counter to the maximum value, which in this case is 50. And then I want to keep looping while the counter is greater than 0. And then each time I'm going to subtract 1 because now I'm starting at 50. So the second time I go through, the counter is going to be 49. Third time it's going to be 48 and so on. And then once it gets to 1, it's going to process, but when it hits 0, it's going to go out of the loop. So this is how that looks. So we start at 50 and we go all the way down to 1. So that's called decrementing. And you can do your for loop either way. This logic where you decrease by 1 is often used in games. Okay, so for those of you gamers out there, if you want to get used to doing it this way, it's perfectly acceptable to do your loop by decreasing. However, most of my examples are going to be increasing the counter because that is, in non-gaming circles, that is what is more widely used. Now, I do have some additional examples for you to look at. And these examples, this one uses the more traditional increment. And you'll see I set it to 1. And instead of using less than or equal to 10, I just changed it to less than 11. And that'll work too, because it'll go through 10 times. The next 2 examples actually ask the user how many times they want to loop, basically. So how many items do you want to buy? We read that in. And then the condition is checking for which is the counter, less than the number of items they wanted to go through. Here we're entering employees. So how many employees would you like to enter? That's stored in number of employees. And then here we are checking the number of employees. Okay, so lots of different ways to set this up. And we already discussed the off by 1 error. And there are a couple different ways to fix this, but since most of you are beginners, this is what I would recommend doing just to keep this straight. So this first example is basically showing that the loop is going to run 1 too many times because we're starting at 0 and we are using less than or equal to. And the fix for this is just to use less than. And in this example, we're starting with 1 and we are checking less than. And so it's going to run 1 too few times. And the fix for this is by having the condition be less than or equal to. And then I do have examples of this as well. Arithmetic shortcuts. So you probably noticed that in the for loops, I kind of use the long method here. The short method, if you're only going to add 1, is to just put 2 plus signs after the counter. Okay, or if you're going to decrease by 1, you put in 2 minus signs. Okay, those are shortcuts. And I would say probably 100% of people who have been in the field and are comfortable with arithmetic would always use the shortcut. They would use the increment or decrement operator. The location of the operators matters if the operator is part of the condition itself. Okay, so if the operator is part of the condition, which means that you are checking it so it's less than or equal to a value, and you're increasing it right in the expression. If you are doing that, the location of the increment or the decrement matters. Because if you put the plus signs or the minus signs after, that is called post-incrementing or post-decrementing. And so what it does is it uses the current value when it's evaluating the expression, and then it adds or subtracts 1. Pre-incrementing is putting those plus or minus signs in front of the value that you are checking. So we're checking counter, and we moved those plus or minus signs before counter. So what pre-incrementing does is it changes the value first, and then it checks, for greater than 10. Okay, so if you use those plus signs in front, it's going to increase or decrease counter and then check to see if it's greater than 10. And this can result in an off by 1 error if you don't initialize counter correctly. So you do need to be a little careful of increment and decrement when they are part of the expression. So in these examples, they are not part of the expression. So it doesn't matter if I do it before or after, because it's not actually part of the expression. So you saw that it worked when I did it after, and it's going to work pretty much the same when I choose to do it before. Okay. That it looks like it's going down. Number, see, there it is, number 50. So should have probably put a space between these. So here you can see we went up, and actually this is where it ends. And then this is where the next one begins. In fact, I'm going to put a space in here just so you can see that I am telling you guys the truth. So I'm writing a blank line in between. All right, there's my blank line. So you can see here we got 49, started at 0, so it did 50 times. Here we started at 50 and went all the way down to 1, so it also ran 50 times. Okay, so doesn't matter if you put these before or after because they're not part of the expression. Now, how can I mess this up? Well, I can move this over here and then get rid of this expression. And this is going to present a bit of a problem. So now what's going to happen is it's going to increase the counter before it checks to make sure that it's less than size. And so it is not going to run the correct number of times. Okay, so you can see that instead of starting on 0, okay, it actually started on 1. And then it ended at 49, so it only ran 49 times. This one, instead of starting at 50 like it was supposed to, it started at 49, and that is how many times it ran. So if you wanted to do something like this, how do you fix it? Well, you'd fix it the same way that you fixed the other one. We want it to run 50 times. We need to do less than or equal to. And here, we'll just do greater than or equal to. So let's run this. So still starting at 1, but now we're ending at 50. Here we're still starting at 49, but now it goes through that last one on number 0, so it runs 50 times. If I put these after, so when you put them before, you need to remember if it's in the condition, it's going to change the value first. If you put them after and it's in the condition, then it checks the condition before making the change. So you don't need to have that equal sign in there because here it is going to keep the 0. And here it is going to keep the size of 50. And after it checks the condition, that is when it's going to increase. Here, after it checks the condition, that is when it'll decrease. So I will show you how that works. So you can see for decreasing, we start on 49 and it did go through 0. So that's 50 times. Here, you can see it ended at 50 and it started at 1. Okay, so this does work. Okay, so, and then you might think, well, you said that it doesn't increase the counter until after checking. Yes. So this is not going to show as a 0, okay, because it's checking to see if 0 is less than 50. And that's true. So the minute it gets done with the check, it's adding to that counter. So it's going to display number 1 here. Now it doesn't do that if we do counter plus plus. Okay, so with counter plus plus, it's going to check. It's going to write this, and then when we come back up, that is when it adds 1. Okay, same with this. We put it over here. So here, it's going to use what the counter was set at, which is 50. It's going to write it out, and then when it comes back up, that's when it subtracts. So what I recommend, because when you're a beginner, this kind of stuff can be confusing. So I would just avoid putting the increment or the decrement in the condition that you are checking. Okay, so if you avoid putting it in here, then it's not a problem where you put the plus or the minus signs. It's only a problem if you put it in here. Okay, and I have additional examples if you guys feel like you need to see more. So just like we have a shortcut for adding 1 or subtracting 1, we have shortcut really for all arithmetic if what you are going to do is add a value into a total or subtract a value from a total, or basically multiply into a total, subtract, divide, or even modulus. Okay, so if the equation is going to look something like this, where you have a value and you are doing some kind of arithmetic to that value, then you can do the shortcut. Okay, and so let me show you in here. And I kind of like increment logic, so I'm going to get rid of this. And so let's say we'll number this. And now I'm going to add it into a total. So I'm going to go ahead and set my total to 0 up here. And I can do total. I can do plus equal counter, and that will add the counter into the total. This is literally the same thing as saying, and I will actually do both so you can see. So these are equivalent. Oops, 2 plus counter. So this statement is basically the same as this one. Okay, it's just it takes longer to enter because there is more text in your statement, and you will pretty much always see developers using the shortcut. So let's do this, and then we will write both of them out so that you can see that they are indeed the same. First total equals, and then we'll say total here. And sometimes it does not actually give me what I want. And let me copy that and paste it. Now we'll do second. All right. So we got our two totals and let's run this. First total, second total, and you can see they are exactly the same. Okay, and this started at 0, ended at 49, so it ran 50 times. So I will show you if you want to use the other arithmetic operators, this is how you would do it. And so now, because I'm subtracting, I'm going to set my totals to a fairly large number. Set it to 5,000. And let's run that. And basically it was subtracting out the number each time, and that is what it came up with. And let's see if we wanted to do a division example. Let's see. So we're going to total them again. And then I'm going to go ahead and divide. So here's our addition. Addition second total. Division. First result. Division second result. All right, so, and we'll do result and then result 2, which we need to create still. All right, so here we go. We will have integer results equals total. It's not going to work. All right, integer total divided equals. We could try that. Yeah, let's do that. We'll divide it by size. Sure. 2. All right. Let's get rid of that. And now we need to add these things. Oop. All right. Equal size. Oh, equals total 2 divided by size. Okay. Oh, and we don't need to declare them again. All right. So we are totaling them, so we'll get a fairly large number, and then we're going to divide it by the size. And so they should end up the same. Okay. Again, just 2 different ways of doing it. And because this is integer division, if we wanted to know if there was any number left over, we could use modulus here. And run that. And then if we wanted to do subtraction, we can run that, just subtracting out the size. Right? And you can see that all of them result the same. So 2 different ways of doing it. I would like for you guys to use the shortcut because that is more of a standard way of doing arithmetic. But again, you only can use the shortcut if you are doing arithmetic on the value that is storing the total or something like that. So here we've got total 2 that we are storing it in, and that is the value that we are going to change. So this only works in those situations. So we've talked about for loops. I've shown you arithmetic shortcuts, talked about the off by 1 error. And now we're going to take a look at a while loop. And so if you have a situation where you don't want to include the counter and you don't want to increment the counter inside the loop. Okay, if that is your situation, then probably should not use a for loop because for loops are designed to do everything in one statement. So what should you use instead? Well, if you have a situation, something like this, and you are just going to test the condition. I mean, this would run, but it's silly to use a for loop because this is what a while loop is for. A while loop only checks the condition. But what that means is that if you're using a counter, you need to create and initialize the counter before the condition is tested. And typically that's right above the loop. And then at the bottom of the loop, you have to change the counter. Okay? And if you don't change the counter at the bottom of the loop, you get into an infinite loop. Okay? And so this will run just fine. You will not have any issues. In fact, I'll go ahead and run it. You can see it started on 0, ended at 49. What does an infinite loop look like? You know when you have one because it does this. Okay, it just runs forever. It never stops. Okay, so that is a problem. Okay, so make sure, and in a while loop, the reason for an infinite loop is because you aren't changing the counter. So the counter started at 0 and it will remain at 0 forever if you don't increase the counter. Or likewise, if you're going to set it to size and you want to decrease the counter. So you want to do this while the counter is greater than 0, right? Okay. If you don't remember to decrease the counter, you also will have an infinite loop. Okay, this will work. Okay, so we're starting at 50. We're going to do this while it is greater than 0. And then each time we subtract 1. So this will work. But if we didn't decrease the counter, it will just stay at 50 forever. Okay, so how you set these up, you initialize the counter, then within the loop at the bottom, you decrease it. While loops are also used if the user has to enter something to end the loop. Okay, and that's a little different code. You still need to initialize the test condition. And the test condition, if the user is going to enter a code that indicates you're done, the test condition is going to be a sentinel value, which means a value to end. And you'll have all your statements. And then at the end, you have to check, ask the user if they want to keep going or not. And if they want to stop, you need to tell them what that character is. So here is an example of a sentinel. As you already saw how a counter works. So this is a sentinel. So I am going to try to copy and paste this. And then we will run it. And so it is not liking some of the characters in the PDF. So I'm having to change the double quotes or retype over them. And it doesn't like the single quotes either. Sometimes PDFs get really kind of funky codes. Has to do with the font that's being used. So let me fix those. All right, so I'm gonna actually kind of repeat the prompt at the bottom here. Well, I can show you what I'm doing. So I've got this in here. The code that I copied had weird double quotes. They're more curled, and C# does not like them. So you'd have to change those if you want to run this. But I'm going to take the prompt and the read and copy them down here because it needs to go at the bottom. And then I don't want to redeclare stop. So I'm just going to put it in like that. And making sure that I'm missing a curly here. Oop, now I've got two sets. All right. And what should I have it print out? I guess we can, let's print out the stop character. All right. So I'm going to go ahead and run this. So okay, let me see. So I'm missing one. That's what I thought. All right. Now it should work. Let's go ahead. Type Q to quit, any key to continue. So I'm just going to press a key. Whoops. Let me activate this. Stop characters F. Stop characters H. And now the way I have it coded, you can do a capital Q or a lowercase. So if I do lowercase q, it quits. Okay, if I did a capital, it would also quit. And that is because I am checking both. But that is a sentinel. Okay, a sentinel can be a character. It can also be a number that, like if you're entering employee information, an employee number would never be -1. Okay, so you could use employee number as a sentinel as well. So how would that look? Enter employee number, -1 to end. So this would be a numeric sentinel. Int emp number, int.parse. And then what we need to check here is the employee number. So it should not equal -1. And then we'll print out the employee number. Okay, and then we are going to change what it's reading in. And we're going to change our prompt. All right, so now instead of checking for the letter Q, it is going to check for a number. All right, so it's employee 10, 20, 30, 40, and now we'll do a -1. And it's done. Okay, so a sentinel is a character that the user keys in. The way that you set these up is the same. It does not matter if you are using a counter or a sentinel. You have to initialize the test condition, then you check it, and then you execute your statements. And then at the bottom, you need to adjust that test condition. So that means changing the counter or prompting the user for input and reading it in. Okay, so here's an example of a counter, and in this case, X is our counter. And for those of you that want to see more examples, I do have full programs that are a bit longer of while loops. And there will be a link to watch a video that explains everything that the code is doing. As far as converting for loops to while loops to for loops, I showed you how to do a for loop to a while loop, and I'm going to show you the opposite. So if I wanted this to be a for loop, I'd have for. This works a little better when it's a counter. Okay, and that is all I pretty much have to do for a sentinel. So let's change this to a counter because a counter's got a little bit more going on. So here we'll have counter greater than size. Oops. Counter is a variable that we have to declare. All right, so if we're using a while loop, we have to create the counter above the loop. And so now we will just print out what the counter is. And then in the loop itself at the bottom, that is where we are going to say counter plus plus. All right, so here is a while loop. And we'll run it. Oops, I didn't print it though. Did I? Counter equals counter. Let's try running. Should work. Interesting. Let me pause it. So if yours blinks like that, you are going to want to either do a read line or a write line to pause it. Actually do a read line, that'll work better. So basically we're going to read whatever is typed and discard it. Alrighty, so here's my code and I'm going to run it. Because let's try that again. It should work. Okay, there it is. And then because I kind of paused it, all I have to do is press enter and it'll finish. Okay, so here, this is a more classic, I guess, while loop with the counter. And this is easier to convert to a for loop. So to convert it, we change while to for. We take this counter initialization and put that before the condition. We're going to add a semicolon, and then we're going to take incrementing the counter and move it after, but that ending semicolon needs to go away. Okay, so that just converted the while loop into a for loop. Okay, and you can see that it did run the correct number of times. Again, if I wanted to do the reverse, I change this to while, pull the counter out, put it right above, take the increment out, put that at the bottom of the loop. And I'm just going to move that semicolon to the correct spot. And now I've converted it from for back to while. And then if you want to see additional examples of for loop to while loop to for loop, I've got examples that you can look at. So at this point, we have looked at for loops and we've looked at while loops. The third kind of loop that we are going to take a look at is a do while loop. And a do while loop is similar to a while loop in that it only includes the condition that you're testing. But a do while loop tests the condition at the bottom, which means that it will always execute the loop at least one time. So when should you use a do while loop? If you want the user to be forced into the loop at least once. Okay, and so how you set this up, you still have to initialize the test condition. That is done above the loop. Then you use the keyword do and a curly brace, all of your executable action statements. At the bottom of the loop, you are still adjusting the test condition. Okay, the while comes after the closing curly brace. And then in the parentheses, it is the test condition that you're checking. So, while the test condition is true, it's going to stay in the loop. Now, the thing that you have to remember about this kind of loop is that it does have a semicolon at the end of the while statement. And all of our other loops do not include semicolons on statements that aren't executable action statements. However, this one does. Okay, so keep that in mind. That is one of those little things that you just need to remember when you are coding this up. So no semicolon on the do, but there is one on the while. Okay, and I do have examples, and what I'm going to do is kind of change this while loop into a do while loop. So I'm going to take the condition and I'm going to move it down here. And I'm going to put a semicolon in. And then I'm going to put the keyword do before the opening brace. And now I have a do while loop. So this guarantees that it's going to go through that first time. Okay. And in an example like this, the do while is fine. I mean, because we want it actually to loop 50 times. So setting it up like this is perfectly fine. And we can run it and you can see it runs pretty much the same as the while loop. If we were going to use a sentinel in here where, the user has to key in something. So we can do character, stop. I would set this to queue. Just because it's going to go through once. So there's really no need to prompt the user at this point, because even if they want to stop, it is not going to stop, okay? Because it's going to go through once. And so while stop, oops. I hate that when that happens. We'll try this again. Stop doesn't equal queue. And I'm going to be lazy and only check for one. All right, so what do we need? First, I'm going to print out the stop character. Okay, my laptop is doing funny things, so we'll hopefully get this working here. Stop equals, and now we'll put out the stop character. And here, cancel that right line. And this isn't going to be very user friendly, but I'm going to just say enter queue to quit. Then I need to read it in. Okay. All right, so let's run this. All right, so it says stop equals queue, which it did because I set it to queue. Enter queue to quit. And now if I do a queue, okay, it did stop. It's on the read line. So I'm just going to press enter again. And let me comment out that read line, because it should work without it. Although I do know some of you guys have had the problem where it just kind of zips through everything. All right, so let me just randomly key in. And let's do a queue. Okay, so the thing with the do while, if you want them to execute the loop once, at least once, use a do while. Otherwise, you can use the while loop. And literally, not a lot of difference between them. I'll convert this back. There is no semicolon. And so in this case, if I keep this at Q, it's not going to execute at all. So let me put something in here so you can see. That's all, folks. Okay. So here I set it to Q. I'm only going to loop while it's not equal to Q. So if I use a while loop here, it's not going to run at all. Okay. Now, what if I put a blank in here? Then it should be fine. Okay. So stop is a blank. And If you would like to see more examples, I do have them with a video explanation that you can look at. When we used a switch statement, you guys saw how break statements work. Continue statements are actually used in loops. And so what will happen in a loop is that from the point of the continue statement down, it skips the code and it starts back up at the top of the loop. And so it does not matter if the test is, true or false in the condition of your loop. It's literally going to skip anything that is below it. So I will make a little example of how that works. So we'll keep it with this Sentinel. And let's see. I am going to continue. So I'm going to say if stop is equal to A. Okay. And then I'm just going to have it skip the rest of the code. And so it's not going to prompt me for another letter. It's not going to read it in. What it's going to do is come back up here and it's going to write out the letter A again. So you can see this is going to be a problem. I'm going to be in an infinite loop. Okay. So got to watch out for continue, but I'm going to run this. Okay, so we'll do a couple of the good letters first, and then we'll do an A. And you can see I am in my loop. So continue, skipped these lines, and went back up here. So I never had the opportunity to change it to something else. So what I can do. Well, if I want to change how this is executing, a break would work. Okay, so if it's an A, what happens when you break is it goes to the next line. And that's what it does in a switch. And that is also how it operates in a loop. So let's not do an A quite yet. Now I do an A. And it broke and went to the next line. So let's do a little different type of equation. So I am going to set this up. I'm going to do a for loop where it is counting down. And if you can divide the value by 2 and there's no remainder, then it is going to skip writing out the value. So I'm going to pause and set this up. All right, so I created this little example that basically allows the user to enter a number. And if they want to stop, they do a -1. And then we read in the number. We check to make sure it's not -1. And then we use the modulus to see if it is even or odd. So if the value evenly divides by 2, okay, it is going to equal 0. And then we would have an even number. Okay, but this is checking to make sure it's greater than 0, which indicates odd. So we're going to print out odd. Otherwise, we have an even number. Okay, so even is going to be 0, odd is anything else for the modulus. Okay, so the way this runs right now is it's either going to print out even or odd. So we'll enter a value. We'll enter an odd value. another odd value, an even value, and now we'll do -1. All right, so let's change this up a little bit and we will do a break. Enter a value, and I will tell you if it's even or odd, -1 to end. You may enter 5 values. All right, so we are going to do a counter. And then we are going to have to increment the counter each time they enter a value. So actually, I'm going to check it here. If the value greater than -1 and the counter is less than 5. And so if all of that is true, then it should execute this code. I am going to format this because it drives me nuts when it's not spaced right. And actually, we probably only need to check the counter here as we're checking the value up there. Now, if it's not less than, if it is 5, then we are going to break so you can see what happens. So what will happen when it reaches 5, it's just going to come down here. So let's run this. So here's our first number, our second number, our third number, our fourth number. And here we're going to try to do one more, 5. And now we'll do another one. Oops, it is not working. So let us figure this out. Oh, not working because we're not incrementing the counter. All righty, good example of what happens. All right, so let's try this again. All right, so we'll do our first one, our second one, our third one, our fourth one, our fifth one. Try to do another, and it should be done. And it is. All right. And I think we could be user-friendly here and put out a message before we break so they know what happened. You entered too many values. All right. So we'll do it again. A little bit more user-friendly this time. Okay. And we could even be more user-friendly by checking, to see when the counter is a 4 and then setting the value to -1. But I think you guys are getting how break works. So we're going to change this up yet again. And we're only going to print out the odd numbers. Okay, so we still want it to stay in the loop though. So we'll change this. I will, whoop. It will display the value if it is odd. Okay. And we'll get rid of the 5 limit. Reading in our value. Going to get rid of this. Get rid of all of this. Get rid of the counter. All right. And right now, it is displaying both the even and the odd value. Okay. So what we want for the else, if we're only going to write out odd values, if it's even, we want to do a continue, okay, which means that it's going to go up here. Now, the problem with that is that we need to move this, or we are going to be in an infinite loop situation. So what we're going to do, we'll keep that in there. I think we're going to get rid of this because otherwise it's going to process funny. And I think we're just going to force them into the loop. So in which case a do while is probably better, but oops. We'll set that equal to 0. All right. So what's going to happen is it's not going to be -1, but we're going to get the actual value that they want to check right here. Enter a value. And I will print it. I will print odd values only. -1 to quit. So we've adjusted our little prompt. All righty. So let's run this. What will happen is we better put something up here so that you can see it's actually skipping. Maybe we'll add a counter back in here. We want to count the odd values. You entered odd values. All right. So let's try this. Enter value, I print odd values only, -1 to n. So we're going to do this one. Okay, so it didn't print it out. So what happened? Okay, we got our prompt. It went in here. It's only going to add to the count or print it if it's odd. 4 is not odd. So it went down here, skipped this line of code, and went back up to check the value. So here, let's do odd value. Oops, forgot string interpolation. Let's fix that. We'll stop it and run it again. All right, enter an odd value. So we'll start again with 4, which it's going to skip. Now we'll do a 3. Entered 1 odd value. Let's do a 5. Now we have our second odd value. Let's do a 10. So it is skipping the print because it basically from the continue on, any code that I have below that's part of the loop, it skips and it comes back up here. Okay. And so we do another even value. It's going to skip. Let's do an odd value. It adds. Okay. And if I want to quit this, I'm going to do a -1. Okay, so that is the difference between continue and break. Continue skips all the code, but it stays in the loop. Break goes to the line below the loop. Finally, our last thing that we're going to cover, which I think you guys are really going to like, is random numbers. And so we do have a random class in C# that generates random numbers. And in order to use this class, you have to create a random object. And then you're going to use that random object to call a method to retrieve the numbers. So to create the object, you're going to use the class name, which is random. You're going to give your object a name, set that equal to new random. Okay, so in this little example, rand is the name of my object. Now, in order to retrieve a random number, I have to call a method that is part of the random class. And in order to call the method, I need to use that random object I created, which I called rand, a dot, and then the name of the method. And so probably one of the easier ones to use is next. And next will retrieve an integer. Now, the default on next is to retrieve a number between 2 and this very large number. But you can control what it retrieves. In the parentheses, if you don't provide a value, it's going to look at this range, this large range. If you provide a value, it will default to the max. Okay, so if you wanted a max of 50, for example, you might think that you can just put a 50 in here. However, that's not quite how it works because it starts at 0. So to retrieve 50 random numbers, it is going to retrieve numbers 0 through 49. If you actually want 50 included, you have to put 51. Okay, so here's a couple examples. So if we create our object and we use it without anything, we're going to get a super large number in this range. I mean, anywhere between 0 and this large number stores as an integer in the variable num. If we just put one number in, that is the maximum. And remember, it starts at 0. So it could retrieve the number 0 through 9. If we wanted to actually include the number 10, we would have to put an 11 here. And then it would do 0 through 10. If we don't want it to start at 0, we need to enter a minimum. Okay, and then you're going to always go 1 over the maximum that you want. So if you want to include the number 50 in the grouping of random numbers, it's 1, 51. And I have several examples. So kind of ignore the links to chapter 3. And here is an example that we can actually run. And there will be separate videos for these examples. But here I am using a for loop, and you can see I'm going to retrieve 4 numbers. And this is going to retrieve numbers from this very, very large range. So here we'll go. We'll run this. Okay, so you can see I have really big numbers. If I want to retrieve a random number between 0 and 9, I put the max of 10. Okay, and let's do this 10 times just for fun. All right, here we go. So that's what it retrieved. All of the numbers are between 0 and 9. If I want a number between 1 and 10, I have to do a 1, comma for my minimum and make my maximum 11. And I did get a 10, and you can see I got some ones in that. So where the random number is often used is to retrieve numbers for math operations if you need to practice, or it is used a lot in games. So you will see I do have several examples here that you can look through. This one is actually retrieving two different random numbers, and it's used in arithmetic. Okay, kind of to test your math skills. This one is simulating rolling a dice, and then it's going to calculate the number of times each dice face was rolled, and that's what it's simulating. So you can see I put the minimum at 1 and the maximum at 7, and that is going to give me the values 1 through 6, which mimic a dice. And then we're going to check the value and basically add 1 each time that value turns up. And you can see I'm doing this 5,000 times. So those are just some examples for you to look at. And you, of course, can copy them and run them yourself. So that is chapter 4. And the lab assignments are going to give you some extra practice on using the loops and also the random number function.